The radio spectrum is a small portion of the broader electromagnetic spectrum. In the EU, it spans from 30 Hz, or 30 waves per second, to 300 gigahertz, 300 billion waves per second, and includes what are called radio waves that are generated by transmitters and received by antennas, and through which wireless signals, coded information and data are folded into to be propagated. As we walk today through Dresden, we are not just walking through its streets, but we are also continuously connecting to and disconnecting from an invisible infrastructure and environment that leaks into and permeates our surroundings. One that we are in touch with, at least most palpably, through our mobile phones.
Yeah, welcome everyone. Thanks for being here. My name is Ignacio Farias. I work at the Humboldt University with a wonderful team. We are together working on an ERC project called Urban Vibrations, how physical waves come to matter in contemporary urbanism. And we are basically working trying to understand how different aerial wave phenomena such as sun radiation, sound waves, but also electromagnetic fields, and with that also 5G signals are becoming increasingly relevant also urban political issue that cities are addressing in multiple ways, where infrastructures are being laid out, but also not just, so to speak, issues of city development or urban planning are connected to these challenges, but also different communities, different bodies are affected in different ways by these different waves.
Thank you very much for being here. It's really great that we can walk together through Dresden, I think. And as you might have assumed already, the problem with wireless technology is that you can actually not see it. And therefore we are extremely thankful, grateful that we can start this endeavor here in the Backhausen Institute, where we will see demonstrators for what you can do with wireless, such as 5G technology.
We work on concrete solutions for processors and operating systems, as well as for communication processes, that we all want to make trustworthy by design. But also science communication is very close to our heart. For example, next generation mobile communications as 5G or even 6G. They offer many attractive opportunities, but they also come with many challenges for modern societies. And this is why we are so well aware of our responsibility to talk about our research. Our aim is to make our own science more comprehensible and accessible for civil society.
Now you can imagine that you are in a special exhibition and we want to speak about signals, that we have something like that as a hexagon that visualizes how strong a signal is in the air, like 5G or Wi-Fi or something else, that families, the children, all the participants who are going to our open space, and it's in the heart of Dresden, so it's like not a hidden lab where people, families, children, non-experts approach us and says, oh, it looks fancy, what is it? If we add some playful components like at the air hockey table.
The robot sees itself and the book with the camera, then he will calculate how he should move. But then this commands will be sent via simulated 3G, 4G or 5G networks to the robot. So you may see that there's a different difficulty between those three standards, which comes exactly from the different latency. So it will lag behind or lag behind less. So just try it out, begin a little bit, and then we can maybe see together how the difference is. So just someone of you can start with, for example, 3G. Press start and try to shoot. Yeah.
So everything is about speed?
More or less. So for this demonstrator, yes. So this is exactly the message we wanted to show here, that it's not only like data rate and difference between the 3G, 4G, 5G standards, but it's also the latency.
And the aim is to reduce the latency to zero?
But I'm happy that we as Germans have some concerns about privacy. Some people have it. We work on good privacy approaches, for example. Others don't care. We think that we can contribute.
One communication application that's very classic is called a downlink, which means we have a base station, which are antennas sitting at top of a building or your Wi-Fi router at home, transmitting information to a terminal, which could be your smartphone, your laptop.
At this demo, we are just interested in the signal strength of a signal in a specific frequency. We are interested how much 5G signal is in front of such a hexagon and want to visualize it.
Funny because it is a question of intensity, right?
Yeah,
there are
exactly. Yeah.
that shouldn't be.
Yes.
Like the classical thing where people are afraid of, I don't even know what. Like there's all these conspiracy theories about the G standards. Engineers really don't understand it because at least in our experience, it's not based on any reality. But what might be possible in future is that Huawei puts up a new base station at the top of your building, and then they figure out how many people are living in there, when they're home, how they're moving. And maybe we don't want that. So essentially, there's benefits to the technology, and I can show you. So since you're all under like the umbrella term of waveform, of waves, this kind of fits perfectly because what this is here, what you can see here is the waves that are currently being transmitted from here and received here. And then on the top left corner there, that's essentially, bottom left corner, that's essentially a plot of the range estimate. It's very coarse. And it also has a screensaver, so I have to touch it from time to time in order not to shut off.
But you play from here.
It should be from here.
And that's a rule?
It's definitely possible. Yeah. Being reflected all the time.
Yes, it's fast. See? But it's stuck there.
So now we're moving on, and I can show you like the direction that we're moving on to. It's like between these, where you came from, Postplatz, and then you basically just walk down this very long street, past the Cultural Palace, Kulturpalast, and we'll hand you a leaflet with a QR code. And if you scan the QR code, then you will listen to our first audio walk talk.
The spectrum itself is an arbitrary construct to organize electromagnetic waves according to frequencies and bandwidths. Since the turn of the 20th century, the radio spectrum infrastructure has been held together through regulations, international conferences and agreements, licenses, standards, national regulators, and equipment like the base stations and antennas in our environments, or the modulation techniques, software, or crystals built into them. But it is also imagined as a finite or scarce natural resource, often compared to rivers, pastures, and oil fields, because there are physical limits in terms of frequencies and technical limits in terms of how well technologies utilize the waves. The need to manage and regulate the finite spectrum began in the early 20th century to combat congestion and interference. More and more users were using the same frequencies, interfering with one another. However, as much as 5G is about developing new technologies, of entering into new spectral territories, it is also about how to differently utilize, manipulate, or extract from spectrum space. The development of wireless technologies is thus also about finding ways to organize these wireless experiences, of finding different ways of sharing and coexisting within space, time, and frequency. So, as we continue to walk through Dresden, imagine this strange, invisible environment that we simultaneously inhabit and experience, both in infrastructure and natural resource. It permeates and leaks around us. It allows us to be in the same space and time in different frequencies, or to be in totally different space, time, frequencies.
What is 5G? I find it helpful to imagine 5G not as a single piece of technology, like a special antenna or a new phone, but as a complex agreement on how mobile networks should work and be built. A standard. Since the late 1990s, standards for mobile communication are roughly developed as follows. The International Telecommunication Union, or ITU, an organization comprised of 193 member states and around 1,000 individual companies, develops requirements or guidelines approximately every 10 years. The company's goal is to secure what it's called a standard essential patent. Owning such an essential patent is lucrative due to royalties and due to increased bargaining power with other companies. It sounds naive, but I was surprised how removed democratic control and public interests were from such fundamental decisions about our technological future. Political observers in the US and the EU realized that the hardware components that are needed for 5G networks could really only be manufactured in scale by 3 companies: Ericsson, Nokia, and above all, the Chinese IT company Huawei. The latter is providing around 60% of active 5G components for German networks, which produce fears of security risks, of cyber espionage, and economic dependency. The current popularity of terms like digital or technological sovereignty and the language of the German government and the European Union show that the development and standardization of digital infrastructure as well as the supply chains necessary to build them are fundamental to contemporary state power. Although it's hard to tell, Dresden is an important element in this strategy. It is a hotspot for research on 5G and 6G technologies and standards, as German network operators run innovation labs in the city and support the technical university. It is also at the center of Germany's attempt to strengthen its semiconductor fabrication capacity, building and expanding production in the northern outskirts of the city. Walking through Dresden, we might then be walking through a new kind of state power in the making, as invisible as the standards and infrastructures it entails, but global in consequence.
Hi, I'm Alex. It's really, thanks for listening to the talk. It's really like an awkward situation to record something and then be present physically when people listen to it.
I'm actually situated in Dresden, and the university and the politicians, they keep telling us, Dresden is really important, it's Silicon Saxony, it's something super cool, semiconductors. But how important really is it? I mean, how does Dresden compare, or what does it compare to in terms of, industrial importance?
So we talked with people from Silicon Saxony, and I think they're actually fairly realistic about what they're doing. Then it also comes down to these issues of investment into semiconductor fabrications, which I'm mentioning at the end of this talk, which is not part of this walk, but is really interesting to go and see Klotzsche, the area north of the inner city of Dresden, where big Taiwanese semiconductor facilities are being built, or a lot of sort of like pre-existing fabrication capacities are being expanded. And it also links to Robotron, because there's a history of microelectronic production here in Saxony.
We are now standing in front of the former canteen of the Socialist Industry Alliance, or combine, Robotron. This was once the nucleus of today's microelectronics stronghold, Silicon Saxony. The canteen served for decades as a meeting place for the large Robotron workforce. In the 1960s, computer technology and microelectronics were regarded as pioneering technologies with high hopes for their development. To underline their significance, the socialist government of the GDR, the German Democratic Republic, developed the site next to the old city, the Dresden Altstadt, as one of the largest and most high-quality construction projects of the 1960s and 1970s. Today, part of the Robotron complex has been demolished. The canteen is one of the last remaining parts of the architectural complex and thus stands for an industry heritage that is today closely associated with wireless technology. There were also demolition plans for the canteen. However, a network of citizens, influential Dresden institutions, including museums, companies, and research institutions like the Technical University, fought for the building and developed new visions. One idea is that the Barkhausen Institute might use the canteen as an open future lab. On its website, the envisioned lab is described as a real-world laboratory and experimentation space, a place of science and digital culture placing humans and their needs at its core. In this vision, the canteen will be, I quote, a gallery of the future that invites visitors as partners and moderates and facilitates debates and responsible innovation.
Jetzt sind wir also angekommen bei der 5. Generation. Eigentlich hatten wir gedacht, es kommt 2020, ging jetzt etwas schneller als geplant, weil alle sich ins Zeug gelegt haben.
Besonders im Hinblick auf diese gemeinsame Diskussion, ich glaube, wir sind alle erwachsene Menschen, aber ich verstehe, dass das mitunter auch mal ein emotionales Thema ist. Nochmal die Bitte in die Runde, wenn Sie Fragen haben. Wir diskutieren das alles gerne auf einem sachlichen, informativen und respektvollen Niveau miteinander. Und ich glaube, dann kriegen wir das hier in den nächsten 90 Minuten sehr, sehr gut gemeinsam miteinander hin.
Und dieser Ausbau wird auch vom Bundesamt für Strahlenschutz wissenschaftlich begleitet werden.
Und wie sieht es denn überhaupt aus, wenn ich dem gar nicht unmittelbar nicht aussetzen möchte? Ist das förderlich für Kopfschmerzen, Konzentrations-, Schlafstörungen? All diese Themen stehen ja im Raum. Gibt es da fundierte Studien dazu, die das belegen oder widerlegen?
Zellen auseinanderstehen, umso höher ist das, was an Strahlung in der Luft ist. Deshalb viele Mobilfunkzellen sind gut für den Strahlung.
Wir bitten den Herrn Theis einmal ganz kurz ausreden lassen und dann dürfen Sie sehr, sehr gerne.
Ich möchte einfach eine Frage stellen oder einfach aus meiner Erfahrung, weil hier geht es ja um Dresden, ne, wo ich sage, wir können jetzt nicht diese ganzen wissenschaftlichen Studien aufzählen. Ich möchte einfach aus meiner Erfahrung sprechen und ich denke, diese technischen Neuigkeiten, die finde ich sehr toll, diese Möglichkeiten in allen Bereichen sind sehr toll. Meine persönliche Meinung ist, der Preis, den wir dafür zahlen, ist zu hoch. Und der Preis ist die Gesundheit und vor allen Dingen die Gesundheit unserer Kinder.
What I'm suggesting now is that that I just give you a very brief input on these protest perspectives, and I'm also trying to localize them a bit here in Dresden. Dresden has always been a city in GDR times that had very little radiation coming from outside, like waves from TV stations in Western Germany, for example, would not get to this place here. This is a group of European people that feel negatively affected themselves, like really bodily affected by electromagnetic fields and waves. This is the camp of the electro-hypersensitive people in Europe last June in a white zone, so where there's very little radiation in the air. And they're wearing yellow shirts because they consider themselves as sanitary humans, like canaries in the coal mine. So the canary is one of their symbols. So this is one very particular issue public around this issue, an issue public that cannot be and defend themselves and represent themselves in public because many of them are really ill and they cannot come to urban spaces to defend their rights as impaired people. Some protest groups think it's a very good strategy to really highlight the health concerns because this is the way you can stop technological development by calling onto the precautionary principle and saying, hey, listen, this is kind of not okay in the European Union to develop further in a technology that might be harmful. From a technology assessment point of view, a risk assessment point of view, there is no need to worry because the exposition that we got from walking to Barkhausen Institute to here would have been like, well, it's always like that, like very much below the threshold values that have been set. These protest groups, they would say, well, the threshold values are the problem because they only consider thermal effects.
Toxic chemicals, for instance, the discussion is usually that it's really uncertain because the thresholds are really unclear of when substances become harmful, and also the question of embedding them right in environments is really, really hard to pinpoint to. And the whole discussion about glyphosate, for instance, right? It's really hard to prove that it's actually being toxic and problematic. And I was wondering how this is with regards to waves and how certain or uncertain is that knowledge actually?
And uncertainty doesn't mean that, I mean, it just means that it's not conclusive, right? And then when you talk to people, and this is what Nona is saying, they would say, we had this wonderful interview with this person in Aachen, STS Hub last year, right? And a scientist, and she was saying, yeah, of course. I mean, we don't know, but I'm like personally 99.9% sure that it's very unlikely that this, I mean, I couldn't imagine how it could be, but we don't have the final studies.
Yeah.
Thank you so much.
Yeah, you're welcome.
Oh, the sun.
Yeah.
My God.
It's nice.